In this video, we want to give a function that meets the given conditions. So we're told that we have a fourth degree polynomial with real coefficients, and the zeros are given to be -2, 0, and 3 plus I. Now, if you have a fourth degree polynomial, you expect to have 4 zeros. Now, they could be repeated, but here they don't indicate. So it tells me that I have to have a fourth one. So here's what we know. That complex number a plus bi, a and b are real numbers, and I is the imaginary unit, which is the square root of -1. A plus bi and a minus bi are conjugates, just like 3 plus I and 3 minus I are conjugates. So from basic theorems of algebra, we know that if r is a zero of some polynomial, then x minus r is a factor. So if I tell you that 2 is a zero of some polynomial, then you know that x minus 2 has to be a factor. That's from the factor theorem. If 0 is a zero, then x minus 0 or x is a factor. Now if the polynomial has real coefficients, and this is the key here, if you're not given this, then we wouldn't be able to do what I'm going to do here. But because we're given real coefficients, if 3 plus I is a 0, then 3 minus I is also a 0. So now we have all 4. So basically what we have to do then is generate the polynomial given the zeros. So I've got 1, 2, 3, 4. So let's do with this. I'm going to call the polynomial p of x. Doesn't really matter. You can call it f of x. And then we just do this. This is going to equal to, first we generate what the factors are going to be. So we know that 0 is given to be a 0, so x minus 0 is a factor. I'll put that in front. X minus 0 is just x. And then for minus 2 is a 0, that would tell me that x minus that number would be x minus a -2. So let's just make that x plus 2. That would be a factor of the polynomial I'm looking for. And then for these two, I'll do it this way, parentheses here, and then 3 plus I is a 0, so I'll just write it this way. That would mean that x minus that number would be a 0, so I'll put that in parentheses, so that would be 3 plus I, and close the parentheses. And then in this one here, this would be 3 minus I, then would be a 0s, so x minus that number, 3 minus I, would be a factor. And that's really your answer. But most instructions will tell you to go ahead and rewrite it so you don't have any imaginary units. You want just real numbers here. So let's do it this way. This then is going to equal 2. And then I can multiply these out. No imaginary units here, so x times x, this will be x squared. Then x times 2 is 2x. So write that as this binomial here. We'll put that in parentheses for now. And then on this one over here, I'm going to rewrite it this way. I'm going to distribute the negative, so this will be x minus 3. And this will be a minus I, so we'll put this minus I over here. And then this one over here, distribute the negative again, so this will be x, and then the minus 3, and then a minus I is a plus I. So the object here, what I'm doing here is simplifying this so that this second half of the expression here doesn't have an I. So notice this is x minus 3 here, that's x minus 3, those are the same. Here have a minus I, here have a plus I. So I'm going to use this formula from basic algebra. Anytime you multiply the sum and the difference, or the difference in the sum of the same two numbers or terms, it's equal to the difference of the squares. So a squared minus b squared. So in this product here, the x minus 3 minus I and the x minus 3 plus I, that represents this right here. So actually I can write this as x squared plus 2x. And then this is the x minus 3 and the x minus 3, that represents the a and the b. The a rather, and the I, minus I and the plus I, that's your minus b and the plus b. So according to the formula then, it would be the square of the first expression, that's x minus 3 squared. And for right now, the whole thing's going to be in parentheses, like that. And then minus the second term, in this case the I squared. So I get this. And so let me just go up here and say polynomial p of x. And all I'm doing is simplifying this over here. So this is equal to, just rewriting it, x squared plus 2x. And now here I'm just going to simplify this inside this parenthesis. So it's x minus 3 squared. That would be just x minus 3 times x minus 3. Any way you want to multiply that, that'll give you x squared minus 6x plus 9. And then here, this is a minus in I squared. And by definition of I squared, complex number, I squared is negative 1. Anytime you square the imaginary unit, you get negative 1. And then you got a minus in front of it, so minus minus is a plus 1. So we got x squared plus 2x, and we got x squared minus 6x plus 9 plus 1. So let's just combine these two here. That's 10. 9 and 1 is 10. Let me just do it here. So this is 10. Now, some instructors will tell you as long as you simplify to eliminate the imaginary unit, you're okay, and they might accept this answer right here. Some might want you to multiply this out. So let's just rewrite this and say, okay, I'm going to multiply the binomial in front times the trinomial. So I'm going to multiply everything first in the second parentheses by x squared. So it's going to be x squared times x squared. It's x to the fourth. And then x squared times a minus 6x, that's a minus 6x to the third. And then it's plus. Then x squared times 10x is 10x squared. Then I'm going to multiply through by 2x. Everything in that second parenthesis times 2x. So 2x times x squared is a plus. That's 2x to the third. And then 2x times a minus 6x is a minus 12. 2x times a minus 6x is a minus 12. It's x squared. And then 2x times 10 is 20x. And then just we combine the like terms. So x to the fourth, we only have one of those, so that stays x to the fourth. A minus 6x to the third and a plus 2x to the third is a minus 4. X to the third. And then a 10x squared and a minus 12x squared is a minus 2x squared. And then we have the 20x. And this is your polynomial, so I can say p of x then. The polynomial that meets those conditions is given by this. Now I want to point out that this is just one example that'll work. It's supposed to give a polynomial that meets these conditions. Well, this is one that meets these conditions. That is a polynomial that has those 4 zeros. You should realize that if I multiply every term by 2, that still will satisfy this condition, because if I put a 2 out in front here, or a 5, or whatever, or just some constant a, where a is a real number, when you plug in one of the zeros, 0 times anything is going to give you 0. So there's really an infinite number of polynomials that will satisfy this condition. We're just giving one, because it only asks for one. And we could give a general rule, like I said, and just put a constant a, put parentheses around the whole thing, and put a, and just say that a is a constant, and that'll work. But this is just one that'll work. Thanks for watching. We'll see you next time.